So let's go ahead and talk about the problem of the day. Be sure to answer the questions I ask out loud and think about how your work is the same or different from what we talk about together. So how could we represent the 7/8 that we need to decompose in this problem? Say it out loud. Yeah, there's different options. One way we could do it is to have 7 fraction tiles of 1/8 each. Another possibility is just to shade 7 1/8 pieces on a picture like this. Okay, so then how could we represent 7/8 using multiplication? Say it out loud. Yeah, we could write 7 times 1/8 equals 7/8. Okay, well, why does that make sense? Say it out loud. Sure, we've got 7 groups with 1/8 in each group for a total of 7/8. That's multiplication, right? We multiply the number of equal groups by the amount in each group, and we find the total. So how is this similar to the addition number sentence we saw from Annabelle wrote in the problem? Say it out loud. Right, in both cases, we have 7 groups or 7 copies of 1/8. In Annabelle's sentence, she added 1/8 7 times to equal 7/8. That's like what we did yesterday. In our number sentence today, we represented the 7 groups or copies of 1/8 by multiplying 7 times 1/8. Okay, so think about the fraction that we started with today. Right? We were decomposing 7/8. What is the 7 in that fraction? Say it out loud. Yes, it's the numerator. And what about 1/8? What relationship does that have to 7/8? Say it out loud. Right. 1/8 is the unit fraction for 7/8. Okay, so then what did we actually decompose 7/8 into? Say it out loud. Oh, right. We decompose 7/8 into the product of its numerator, right, 7, and its unit fraction of 1/8. So let's take a minute and think about what else this teaches us about multiplying fractions and whole numbers. Okay, so when we multiplied a fraction times a whole number, what did you notice about the numerator of the fraction from the factor to the product? Say it out loud. Right, the numerator of the fraction changes, doesn't it? And why does that happen? Say it out loud. Right, it happens because we're changing the number of parts that we're talking about. So in this case, we started with 1/8, multiplied that by 7, and you ended up with 7/1/8 or 7/8. So I want to make sure that we remember that. Read this key point with me. When we multiply a fraction by a whole number, the numerator changes because we are increasing the number of parts. Great. And what do you notice about the denominator of the fraction from the factor to the product? Say it out loud. Right? It stays the same. And why is that? Say it out loud. Right, it doesn't change because the total number of parts in one whole doesn't change. We're just increasing the number of parts that we're talking about. So this is our last key point. Read it with me. When we multiply a fraction by a whole number, the denominator does not change because the number of parts in one whole stays the same.